Alright, welcome back. This is my video for lessons 4 through 6 in fractions. Lesson 4, I'm not that crazy about, and the students actually ended up not being too crazy about either. Basically, we were taking these same tape diagrams, and now we're just starting to cut them into smaller pieces. And when we do that, we create equivalent fractions. And so in letter C here, I have to cut this. I have 1/4. I have 1 out of 4 pieces, and it says in the directions that this is equivalent to a whole. So I have 1/4. Well, if I go in and I cut each piece in half, vertically like so, I end up with a new fraction. And my new fraction is the same 3 questions. 1, how many pieces do we have now? And we have 2 shaded parts out of 1, 2, 3, 4, 5, 6, 7, 8 shaded parts. And as a number sentence, I could add 1/8 plus 1/8 is equal to the 2/8, but that's also equivalent to 1/4. And so we're learning how to create equivalent fractions. We're not adding to the shade or taking away from the shade. We're just breaking our cake into smaller pieces. And so nothing about the amount of our cake changes. We just have smaller pieces or bigger pieces. We're just being what we call cake cutters. In the second example, I could cut it instead of into 2 pieces, I'm cutting each piece in thirds. So I still had 1/4 to start with, but now I have 3 shaded pieces out of 3, 6, 9, 12 total pieces. And I could also record this as multiplication and say this is 3 times 1/12 is 3/12, or that's still equivalent to the 1/4 I started with. It took a little bit for students to grasp that concept, and the next day we came back and basically we did the same thing, only we used a different model, and this model is called the area model. So it's the exact same model we use for area, and it's exactly like arrays, which we have used since the first week of school. And so what we do here is we draw an area model, which is essentially just a larger tape diagram. And it's more square-like, box-like, and it's just bigger. It's easier to see. The students are used to working with arrays, and so they really picked up on this more. We do the same thing, so we cut this into thirds, and in this case it says we have 1/3, and so I go in and shade this 1/3. A lot of students seem to like to use highlighters, and that's perfectly fine by me, and they seem to like to use colors and things like that for their pictures instead of shading. And so I still label this as 1/3. Now they wanted us to show that 1/3 is equivalent to 2/6. And so instead of cutting these pieces vertically, all we have to do is cut them horizontally. And we usually have the students use dashed lines to show that this was where they cut. And now you can see that after making that cut in my cake, now I have 2 pieces out of 6 total pieces. And so I just turned 1/3 of a cake into 2/6 of a cake. And they want me to represent this decomposition as the sum of unit fractions and a multiplication sentence. Again, the vocabulary is very mature, but as we hear it over and over and over, it starts to become very clear of what is expected. And really they want us to show that, I'll have to do it down here, that 1/3 is what we started with. We broke that into 1/6 and 1/6, which was equivalent to 2/6. And so when we're writing the sum of unit fractions, we're adding each piece. To show multiplication, we still started with 1/3, and we have 2 1/6, so I multiply 2 times 1/6, also equals 2/6. When students did this lesson, they picked up on it very quickly. And I'd say everyone, pretty much in every class, agreed that they liked the area models better than the tape diagrams. And in lesson 6, it was essentially the same thing, only this time, instead of starting with 1 piece of cake, we're starting with more than 1 piece of cake. And so in this instance here, we're starting with 3/5 of a cake. So I draw the same whole, same cake, but this time we have 3/5, which is 4 cuts. 1, 2, 3, 4, and I'm shading 3 of these pieces and labeling my area model as 3/5. Now they want us to show that 3/5 is equivalent or the same as 6/10. And so students have to decide how many times horizontally do we need to cut this into how many pieces to end up with 6/10. Well, 3 times 2 is 6, and 5 times 2 is 10. So I need to cut each piece make it from 1 piece to 2. So I just need one horizontal cut to end up with 1, 2, 3, 4, 5, 6 out of 7, 8, 9, 10 pieces. So we have 6 shaded, 10 in the total. The third question is always, what is each piece worth? Well, this piece right here is 1 out of 10 pieces now. 1 out of 10 pieces. And that third question is kind of what gets students the most. This is 1/10 of this cake. And so to add up each piece, we call this the long boring way. I have to add up 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10. And this was all equivalent to 3/5. I could also show this as a multiplication sentence, and it could go the other way. We started 3/5, and 6 times, we have 6 pieces of 1/10 is equal to 6/10. We also sometimes represent this with parentheses, and we make different groups. So in this case, let's say I want to put these in a group and these in a group. Well, this number sentence would be that we started with 3/5, and that's equal to 2 times 1/10, which is this pair, plus 4 times 1/10, which is this pair, and that's still equivalent to 6/10. This was very tricky at first. This was called the sum of two products. So we added 2 multiplication problems just by breaking this into groups. And there's different answers you could have here. Overall, students improved a lot from lesson 1 to 6. I keep telling them that, it's tough to get the ball rolling, but once it's rolling, I really think that we're going to continue to do a great job, and it's starting to become a lot smoother, and students know what to expect. But we will soon review everything that we've learned and take a quiz just to assess what students really truly understand on their own. And I will continue to post videos to show examples of all these fractions that we're doing. You can always request other videos, or if you don't understand the videos, you can comment and I can get back to you with your questions. All right, thank you.